Today we're going to be learning about working with two-column proofs with similar triangles. So if you remember, we did this to prove triangles congruent, so this time around we're doing it to prove them similar. Remembering once again that triangles are similar, meaning they have the same shape but not the same size. So all the angles are congruent and the corresponding sides are proportional. All right, so we've already learned 3 different postulates that we can use to prove triangles similar. They are angle, angle, side, angle, side, and side, side, side. These are the only 3 that work. And when we talk about angles, once again, we're proving them congruent, and sides, we are proving them, the corresponding sides, proportional in length. Okay, so let's go through and let's take a look at a proof together. So example number 1, complete the proof. So our given, AC is parallel to MP. And we have to prove that triangle ABC is similar to PBM. Okay, now, if you are given something, a piece of information, you're given it for a reason, meaning it's telling us something. Okay, so what I tell my students is always go to the diagram and mark things that you can mark first. So the arrows proving parallel are already on our diagram. But what does it mean? What do parallel lines tell us? They give us congruent angles. Okay, so I'm going to go and mark some stuff. If these 2 lines are parallel, then I can say that angle C is congruent to angle M. Why? They are alternate interior angles. They're on opposite sides of this transversal down the middle. Okay, this guy right here. And they are on the inside of our parallel lines. I can also say that A is congruent to P. Okay, now before we go on, what else can we conclude? I'm going to erase these lines right here. I know that not only this right here, but I also know that these 2 are congruent right here because they are vertical angles. So always go to your diagram and see what information you can pull out first and use that to help you to prove similarity. Okay, now I only have 3 reasons to pull from: angle, angle, side, and side, side, side. Well, look at it. All the information we're talking about is angles. So it makes sense that we are going to use the angle, angle postulate in this proof. Okay, let's start jotting stuff down. Also, it's important before you start to look at what triangles you're proving congruent. Here it's ABC and PBM. I'm going to outline them in different colors. Okay, because sometimes you'll see in a further example there's more than 2 triangles there, so you got to make sure you know which ones you're looking at. All right, so the first thing that we always write in is the given. So that is going to go in step 1. AC is parallel to MP. Given. Well, we already talked about it, and we know that we're trying to go with the angle-angle postulate because we know nothing about side lengths. All right, so let's start out by, now we have to make our statements. We need to prove at least 2 angles congruent. So let's start with the vertical angles. Okay, so I have angle ABC, and that is going to be congruent to angle PBM. Okay, so these right here. And the reason for that is vertical angles. So what we again are doing in the statement column is listing the congruence or the proportional side lengths if that was happening in this picture. That's not. Okay, so we need to write down all this information. All right, and then I can also say that angle C is congruent to angle M. I also can say angle A is congruent to angle P. Now I do not need all 3 angles, okay? I do not need to prove all 3, I only need 2. But I know that both of these work because they're alternate interiors. So let's come back to that thought in a second. So really, I can do a vertical angle and then one of the alternate interior angles, okay, because I don't need to list all 3. Or we could have cut this proof down by 1 step and we could have cut out line 2. We don't need the vertical angles because we only need 2 angles. And when I have parallel lines cut by transversal, I get 2 sets of alternate interiors. So just something to think about. All right, my last step, I have my angles in there. So make sure that you have enough information. And I can say that triangle ABC is similar to triangle PBM. Why? Our angle-angle similarity postulate. So angle, angle. If you need to, pause the video, rewind, and go back and watch that proof again. All right, number 2. Given ABCD is a trapezoid, we are proving AED is similar to CEB. All right, here's an example where you have quite a few triangles. So I'm going to highlight AED. It's off a little, but you get the idea. And then this one down here. So we know which two we're looking at. Okay, now, before we get started with the given, what do we already notice? If you said vertical angles, you are correct. If you notice that my lines are off, that's not helpful information. All right, so I have vertical angles. Okay, now ABCD is a trapezoid. Remember, if you're given something, it's for a reason. You learned about trapezoids way back in the day in middle school. You may or may not remember, but in a trapezoid, line AD are two bases, so AD and BC are parallel. Okay, I'm just going to jot that down right here. AD is parallel to BC. We'll talk about that in a minute, how to put that in our proof. But what do parallel lines imply? Alternate interior angles. So once again, I can say D and B. And then this one with this one. Okay, so once again, I'm looking at angles, not sides. So this will be an angle-angle postulate. Okay, so let's talk about our reasons in our statements. First of all, given, always. It's a trap. Okay, now, we can just go ahead and state our vertical angles because that's something that we don't need a given for. It's truth anytime things cross each other. So looking at our diagram, we have angle AED is congruent to CEB. Why? Definition of verticals. All right, now we're going to go back and we're going to pull up the other angles, but we need to state this statement right here. Okay, we're given that it's a trapezoid, but what does a trapezoid imply? It implies parallel lines, which thus then implies angles. So we have to provide every step. So here we're told it's a trapezoid. So down here we're going to write that parallel statement. AD is parallel to BC. Why? All right, we can say definition of a trapezoid. We can say bases of a trapezoid are parallel, however you want to word it, but knowing that trapezoid implies that. Okay, so if you write something in your proof, once again, it is for a reason. Why did we write that? We wrote that so that we could say that our angles were congruent. Okay, once again, I don't need both of the angles, both of my alternate interiors in this case. I'm just going to write them both so we can see it. But keep in mind, we only need two sets of angles, so we could have really taken out step 2 if we wanted to. All right, so here we go. We're going to write our angles in. Angle ADE is congruent to angle CBE. Oops, angle sign. All right, and then angle DAE is congruent to angle BCE. Why? Alternate interior angles. All right, we have enough information to now conclude the triangles are similar. So triangle AED, similar to triangle CEB, angle-angle postulate. Notice we're saying similar here because it's not congruent, so you need to state it's angle-angle similar postulate. All right, first step, should always match your givens. Last step, what you're proving. Once again, pause the video, go back if you need to see this proof again. All right, now this next proof, we are going to be learning a new concept in here, so make sure that you are really paying attention. So we're given that T is a midpoint of QR, U is a midpoint of QS, and V is a midpoint of RS. All right, what does midpoint imply? It implies that it's cutting a diagram a line in half. So if T is a midpoint of QR, that tells me that these two little line segments are the same length. All right, then it tells me that U is a midpoint of QS. So these two are the same. And last but not least, V is the midpoint of RS, so these two are the same. Okay, now let's take a look at what we are going to prove. All right, I don't have any angles I can do here. There's no verticals, there's no shared angles. Okay, so we're proving that QRS is similar to VUT. So let me draw that. QRS is the big guy, and UVT is this little guy. I'm going to make him in a wavy line so you can kind of see the difference between the two. Okay. So once again, no shared angles. So clearly, the only thing we're looking at is sides. Okay, I don't have any vertical angles, like I said. I don't know any parallel lines, so I'm not going to grab any alternate interiors. Okay, no corresponding, so therefore it's probably going to be a side-side-side postulate. So let's look at it. Given the information we have and the markings that I made, how is that going to help us say that QRS is similar to VUT? Based off of that, it's not going to, okay? I can't conclude anything based off my markings, okay? It doesn't matter to me that those two are equal, because that's not, both of these little halves are not part of the little triangle in the middle, right? They're true facts, but they're not going to help me. So here's what's going to be new. So let's go ahead and everyone, let's write the givens in. So fill in all this information, please. While I write it too, you do as well. So how's everyone's night going? Having fun doing math? Okay, so if you need more time, pause it so you can write it and then move on. All right, my givens are given to me. Now, here's what happens, and this is a new fact, so you probably don't know this, and that's okay. Take a look at line UT, or TU. This line right here is 1/2 the distance of RS. Okay, why? Because of this. Because of the fact that T is the midpoint of a line and the fact that U is the midpoint of another line, that means that the line that those two midpoints form is 1/2 of the third side of the triangle. Likewise, UV is formed by the midpoint U and the midpoint V. So therefore, UV is 1/2 the distance of this guy. And last but not least, oh, I can't even read my markings anymore. TV, which you probably all rather be watching right now. T and V are midpoints of two lines of the side, and the side that, or the line that they create is half the distance of this line right here, the other side of the triangle that doesn't have a midpoint on it. So that being said, my little circle in the middle, the red, green, and blue one, this little guy right in here, all the sides are 1/2 the distance of the outer sides of the big triangle. So that means if they're all 1/2 of the distance, if I were to tell you that this guy was 10, the other green one would have to be half of that, 5. All right, and I'm just making up numbers so you can see it. If I tell you that the blue one is 12, the other blue one has to be 6, 1/2 the distance. If I tell you this one is 20, this one is 10. So that means that the sides are truly proportional. So we can conclude a side, side, side here. That is the new fact that we are working with. Okay, all of the sides of the little guy are 1/2 the distance of the corresponding the corresponding sides of the bigger triangle, okay? And that is because they were all formed by midpoints. Not just doesn't happen in any triangle, it's because this red line right here was formed by 2 points that are midpoints of the other two sides of the triangle. So let's figure out how to write this in. Okay, let's start with the green line, TU. All right, so TU, and I'm not putting a bar because we're talking length now, is 1/2 the length of RS. And remember, we learned in Unit 1, we say length without putting the bar, that means length. Okay, here is why. The segment, so this is how we're going to word it. The segment connecting the midpoints of two sides of a triangle is 1/2 the base. All right, the segment that's connecting the two midpoints, this green one right here, it's connecting these two midpoints, is 1/2 the distance of the base, meaning the other side of the triangle that doesn't have the two midpoints on it. Okay, now I'm going to write the same reason for the next two. So if you want to pause the video, I'm going to go ahead and pause it and write it in just to save a little bit of time. So you can pause it too and write them in on your own. So the reason it's going to be the same for 3 and 4, I'm just going to have to use different lettering. So try to come up with these on your own, the sides that we're talking about. Okay, so I just paused it to fill in that information. So UV is 1/2 QR, the distance, and TV is 1/2 QS. Okay, so with that being said, I can now conclude that the two triangles are similar because of the side, side, side postulate, because all the sides are proportional length. We don't know what they actually are. The numbers I put in were just to help you visualize it, but we don't really care. We just know that it's true. So side, 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 similarity postulate. Okay. Pause the video, go back, rewind if you need to. You're going to move on to the last example. So the last example is doing a proof on a coordinate plane. So we're given triangle ABC and TBS with given vertices, and we have to prove the ABC and TBS are similar in similar. So guys, if it's on a coordinate plane, think for a second, what postulate do you think we're probably going to use? If you thought to yourself it's side, 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 you are correct. Right? Because we're not really talking angles here. We know on a coordinate plane how to find the length. Okay, so we're going to use that, side, 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 length. Okay, so let's go ahead and plot our points. A is at -2, -8. -2, 1, 2, 3, 4, 5, 6, 7, 8. Way down here. All right, B is at 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. So you can be doing this with me. You don't need to just be watching. -2, 7 is here. All right, now my other triangle, I'm going to do in a different color. T is at 0, -4. It has the same point B, okay, because I'm doing TBS, so TB, and then S is at 0, 6, which is right here. Right, 1, 2, 3, 4, 5, just kidding. Right here. Okay, so here's my smaller triangle. So we want to prove that these two are similar. Okay, ABC and TBS. Now, just find the lengths of the sides. Let's see if they're proportional. Okay, so pause the video on your own. Find the length of those sides. You guys should be pros at length by now. If you're not, you need to be coming in for practice. Because at this point, we expect you to be able to do it on your own. So pause the video. All right, match up your lengths with mine. If you got something wrong, try to find your mistake. If not sure, once again, you need to come in for help. All right, so if I'm going to be proving that these two are similar by side, 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 I need to find the ratio of the corresponding sides. So I know that AB and TB correspond, okay, because they share, like they go over each other. So I'm going to do a ratio of AB over TB, which ends up being the square root of 180 over the square root of 80, and when you do it on your calculator, it reduces to 3/2, 3 over 2. Keep that as a fraction, please. BC corresponds with BS. The square root of 45 over the square root of 20. And how am I figuring this out, guys? I'm typing it into my calculator, and you probably get a decimal, so then I'm math fracking it. Math, enter, enter. And I get 3 over 2 once again. All right, and the last one, CA over ST is 10 over 15. I'm sorry, 15 over 10, which does reduce to 3 over 2. Okay, if you need help with reducing, type it in, do the division, get a decimal, and then math enter it to get the fraction, okay? So they are similar because all three of these are the same. If even one of them was off, they would not be similar. Okay, so they are, ABC is similar to TBS by side, side, side. Bonus question, what's my scale factor? If you can answer that question, write it on your paper, bring your answer to class, and your teacher will give you a high five. We are done for today.